Welcome back. Got a quick video today. I was messing around with the soldering iron the other night because I felt like putting something together. And you know I like my LED projects and stuff. So I decided to build a little LED light unit. But the difference between this one and the rest of them is this one's actually a very specific unit. And I have it mounted up here, just a little off camera. And I have it up there for a reason. The last video I did, and I think the one before that, this was kind of sitting in the background and it was giving me just a little bit of extra light in my desk. Now, I say extra light. Right now this desk's pretty freaking bright. In this lamp right here is a 10-watt LED that's running off of a 12-volt converter inside the base. I've converted this lamp years ago. Unfortunately, I didn't have the YouTube channel. Pelleggi Technical Services wasn't even really a thing. I used to call myself C. Pelleggi Productions, and I worked out of my shed and I made little odd things and never took any video of it. I had some pictures and stuff. I always take tons and tons of pictures, but I just never had any video, never explained how I did these things, and that would have been a great thing to do a video on, and maybe I still will. I'll show you what I did with it. But anyway, there's a heat sink in there, there's a 10-watt LED. Just above that, hanging from the ceiling, is another fixture that I made. And this one has a 120 volt to 12 volt switched mode power supply up here in this box with a fan on top of it. And originally this was made with red, green, blue LED strips. In fact, they come in 16-foot rolls. The entire 16-foot roll worth of red, green, blue tape is on this thing. They're doubled up, and this is 4 foot long, so there's four 4-foot long strips here. And in the middle is white double wide tape, obviously 4 foot long. And since it's double wide, it's effectively the same brightness as 8 feet of tape, if you will. So I have that just to give general light to the entire desk area here, whereas this light is just more general one spot of light. And if I zoom down, you can see everything is bright, but the middle of the desk's the brightest. And then obviously where my custom power supply sits in the middle here, I took, I'll back up a second. These boxes here that you see, there's one here, one on the bottom, and then one of the supplies, and somebody made me a bunch of them, and they were intended to be boom boxes, and I never finished the project, honestly. So I decided to finally do something with it, and I made the power supply, and then I ended up making the organizer system here, and they're all just nailed together and whatnot. And then one day I decided to take the leftover tape I had from the overhead light project and cut little strips and put little strips of LED in each individual little pocket here. And that just doesn't really provide any more light out here onto the desk, but what it does do is it lights up the background here. And I even have a little box that I made with my logo with the same lights, and this is just strips of light around all 4 edges, and they run off the power supply here. So if I go ahead and I kick this off, you'll see that that whole section dies, and then obviously the other ones still stay lit. If I even go ahead, this top one has a pull switch. You can see, yeah, the 10-watt LED light is nice and bright if you're just sitting underneath it doing stuff. I mean, here's the schematic I did for the last project. You can see it lights up nicely. But just adding that extra background light and then adding these lights, it just kind of, ties everything in nicely. And there actually is one more light in the room. If I want, I could turn the ceiling light on, which has the standard incandescent bulbs. It's just one of those, 3-lighter ceiling fan units. That again just provides more general light. Ultimately, I would like to have a couple LED studio lights, if you will, kind of hovering over me here, just to give more light, and you won't have this reflection of glare and shadow and whatnot. It would kind of help eliminate that. But with that, I'll introduce the little module I made. Now, speaking of power supplies, you'll notice that this power supply is broken up into 3 voltages. There's a 12 volt, a 5 volt, and a 3.3 volt. LEDs, for the most part, run at around 3.3 volt. In fact, the white LEDs have a range of 3.2 to 3.4, so that 3.3 is obviously right dead smack in the middle of that range. some LEDs, like your red, they tend to run on 2.2 volt or whatever the situation is. Actually, I have a little chart here. Yeah, the greens, blues, whites, and UV LEDs all running at we'll say 3.1 to 3.2, 3.3 range. I have green listed as 3.1 to 3.2, whereas the blues and the rest of them here pretty much go 3.2 to 3.4. So I'd feel much more confident running those colors on the 3.3 volts, where green I wouldn't necessarily feel as confident. A couple of the colors though, like yellow, red, and orange, they run on the 2.0 to 2.2 range. So those lights, those particular LEDs, would need a resistor. And resistors just taking the extra voltage and dropping it down. The things about LEDs is if you don't have the right voltage, they pop. The other thing though is this 3.3 volt output here is actually rated for 14 amps. So, you know, theoretically, you know, one way you have too much current, one way you have too much voltage. And luckily, that particular setup here, I'm not putting that much current into the light. I'm only putting what current the LEDs will take, and not the full 14 amps to come out, because otherwise you would just hook up an LED and it would just fry. So I got playing around one night and I just took one of my LEDs and hit it across the leads here, and of course it lit right up. Now, it's kind of an aside, but that's one of the reasons why I love converting these ATX power supplies. That's because they're that much versatile. They're that versatile. You can do that many different things with it. 12 volt is obviously a very common power setting. You know, all these LEDs here run at 12 volts. So if I really wanted to, the ceiling light, the table lamp, I could run all that off this power supply with room to spare, easy. 5 volt, that's USB voltage right there. You know, you could actually make a lineup of USB ports, if you will, and make like a giant charging hub and just base it off that 5 volt output there. But the 3.3 volt, it's not as useful to me unless you're powering LEDs. So I said, I can power an LED directly off that without any resistor. What if I built a line of them? And that's what this is. It's a line of LEDs that they're just soldered to a circuit board with a positive and a negative, and obviously this won't work on any other voltage but that 3.3 volt setting. I'm sure if I take a couple batteries, I can put them together and it'll work just fine, as long as it's 3 volt. It should light up. A lot of those flashlights you buy, like this one here, are set up that way. But the differences with these is all those LEDs are hooked up together, not in series like this would be. They're all hooked up. All the positives are hooked up to one connection, all the negatives are hooked up to another connection. And there's actually 3 cell batteries in here. So you're getting 4.5 volts, which obviously is higher, but because the current drop, I guess you could say, of all the LEDs collectively equals more than, what's the best way to say that? You're limiting the amount of voltage going to all those LEDs because there are so many LEDs. If you took 1 or 2 of those out of the mix, you'd probably pop the remainers because you're putting too much voltage to them. Could they have used 2 batteries in there instead of 3? Not sure, because that's only 3 volts. It's not enough. So that's very possible, where 3.3 is like, that's the magic number. So what I did with this is, as I did want to make this a quick video, is this is just one of those 2-sided perf boards. I've used these before in a ton of, you know, projects. They actually come in a 4-piece. You could split it 4 ways. I just split it in 2 like that. They're all hooked up together. And what I actually did here was I put a little terminal block on the back side. And there's, you know, your positive and negative, obviously. The positive is the top rail, and that hooks up and that goes all along here. Now, all these little segments on this board, maybe I can show you on the other one. Wherever you see these white lines on here, those means those pads are connected. So this section here is connected. Those 2 are not. this next section is, that section is. You get the idea. So on this one, this entire bottom section here is the positive rail. They're all connected. If you flip it over, you'll see that the LED actually just jumps right to it. So they're sitting in this little pad here. The positive wire goes directly to the positive rail. Then the negative side has a wire lead to it, and that goes to a little switch. I have 6 LEDs on here, and I have a 6-position switch. So if I want to, I can actually shut them off and just have one light on here. Now I know this isn't a useful thing. It's kind of a gizmo more than anything. I'll show you what I mean by that. If I go ahead and put this on the right way here, you can see with the switch lit, there's the 2 outside ones. And then if I want, I could flip on the middle one like that, or I could turn all 4 of them on, or all 6, I'm sorry, I could turn them all on. Or if I want, I can just have 2 in the middle on. And obviously the more LEDs you have, the brighter it gets. Now there could be an application for this. Maybe I could do something with my Halloween pumpkin. But anyway, the other thing I did with this is I put a capacitor on the back for no reason. It's just jumped across the positive and the negative, and all that really does for me is when I connect the power to it, the LEDs will light, that charges the capacitor, and then if I disconnect the leads here, the LED will stay glowing for just a split second. So I'll go ahead, I'll turn one of these on, and then when I disconnect it, it kind of has like a little fade out, and you can see it glows ever so slightly until it dies. If you had enough capacitors, or large enough of a capacitor, you could probably get a little bit of runtime out of that, but it kind of gives it like a little soft delay off. It's totally not necessary. I just had it, I got happy with the soldering iron and just soldered it on. But what I did do, which is kind of cool, is I set up my helping hands here, and let's see if I could replicate how I had this. I had one of the clips clipped onto the negative side, and then the other one wasn't clipped to anything at all. And then I took the positive and connected that directly to the helping hands like that, and then took the negative and connected it to the negative rail. Oh, backwards. There we go. And turned all the LEDs on like that, and I sat it up here in the corner, and I realized, wow, it actually makes a nice little spotlight on the table, which is interesting because you would figure with a 10-watt LED and however many total watts I get out of everything else here on the table, this wouldn't happen, you know. I mean, look at what we're looking at here. We're looking at those 6 LEDs, and we're comparing it to that guy right there, and I can tell you that there's actually 9 individual light emitting pieces on this main chip here, and I'm shocked actually that it provides that much light. I was trying to see if I could maybe, no, that's not going to work. Anyway, yeah, I thought that was kind of neat. It just provides just enough little light there, or if I put something on it and I zoom in, I can really see it pretty clearly. And I would have never have thought that, like I said, 6 standard 5mm LEDs would provide enough light to do that. So it's kind of neat. Again, how many applications does it really have? But sometimes, you know, you got to play around with these little things and make it little interesting little projects. But with that, that's all I have to say, and thanks for watching.